Hi friends, welcome to my another video. Today in this video, I will discuss about motor size calculation for pump. This video is very important as we have always a confusion that which rating motor we will select for our pump. Like in our home, which rating pump we should select in order to drive the water from the ground floor to the top floor in the water tank. This video will give you an overall concept also in order to calculate any other types of pumps, as the motor is not only used for the pump application, it is also used to driving a mechanical load. It is also used in the air compressor. It is also used in the fans for the ventilation system. So this video will give you overall concept. The sizing of different types of pump will be different. Like in order to size the booster pump, in order to size the circulation pump, in order to size the transfer pump, irrigation pump, chill water pump, firefighting pump might be different, but the concept which I will discuss in this video will be helpful to size other types of pump also. Basically, in this video, I will size the motor HP rating or kWh rating for transfer pump. In order to better understand this topic, we have to understand some terms which I will use throughout in this video. So let's start this video. The first term which I will use throughout this video is a flow rate. So what is flow rate? Flow rate is a measurement of a volume of liquid that move in a certain amount of time. What does it mean? Suppose I have a pipe and there is a water flow from this side and we are getting water from this side. Okay, in 1 minute, how many liter of water I am getting, that is called the flow rate. Okay, means how many quantity of water I am getting in a certain interval of time is a flow rate. Suppose this bucket is of 10 liter capacity. 10 liter water will come in this bucket and this tap is filling this bucket in 10 seconds. Okay, then the flow rate will be 10 liter divided by 10 second, that is 1 liter per second. So the flow rate of this tap is 1 liter per second. What information we got from this flow rate? It indicates that this tap is delivering 1 liter of water in every 1 second. Hope you understood this flow rate, because this is the key point to understand the full topic, that is how to size the motor size for a pump. So there must be no any confusion in the flow rate. There are other units also for the flow rate. The SI unit for the flow rate is meter cube per second. Other units are liter per hour or GPM. What does it mean by meter cube per second? Suppose this tank is 1 meter in height, 1 meter in width and 1 meter in depth. Suppose this tap is taking 1 minute in order to completely fill this 1 meter cube of water tank. Then what would be the flow rate of this water tap? The flow rate for this water tap will be 1 meter cube per minute. But if I want this flow rate of this tap in SI unit, then I have to change this minute into the second. Then the flow rate will be 1 meter cube in 60 seconds. If I will divide 1 by 60, then it will come as 0.016 meter cubic per second. So we will say that this tap have a flow rate of 0.016 meter cube per second. I'm emphasizing this flow rate concept because it is very important to understand the pump calculation. The other most important concept in order to understand the pump size calculation is head. What is head? Head is the maximum height that the pump can move the fluid against gravity. There are 3 types of head: delivery head, suction head and friction head. Okay, we will discuss each of them one by one. What is delivery head? The maximum possible height between the delivery port of the pump and the water outlet points. Here you see there is a delivery head of the pump, delivery point of the pump, and this pump is delivering the water against gravity to this water point. So the height between the delivery point of the pump and the water point is called the delivery head. Okay, if you will see the suction head, then the height between the water level in the sump and the suction port of the pump is called suction head. What does it mean? Here you see there is a suction point of the pump, and this is the water source from where the water is sucking by this pump. So, but there is a height, there is a clear height between the suction point of the pump to the sump where the water is stored. So that height is called suction head. Hope you understood. Now the other head is geometrical head. What is geometrical head? The sum of the delivery head and the suction head is called geometrical head. Geometrical head in different cases can be different. For example, here, as I told you, in this case, the motor has to work to suck the water against the gravity, and the motor has to work against the gravity to deliver the water in this case. But in this case, the motor is not working against the gravity in order to suck the water, because the motor is below level than the water from where it is sucking the water. But motor is working against the gravity for delivering the water to the water point. In this case, the motor is working only at the time of delivering the water against the gravity. In this case, the geometrical head is the difference of delivery head and the suction head. So it will change situation to situation. You have to analyze this one, okay? Now let us discuss about the friction heads. As we know that when the liquid will flow through these pipes, then there will be a friction between the wall of the pipe and the water. And the motor has to overcome this in order to deliver the water to the delivery point. So motor has to work for the frictions which offering by the water and the wall of the pipe. So it is due to the pipe material, it is due to the pipe size, it is due to the fittings which is fixed in the network, like the valve, like elbows, T's and everything. Due to that, there will be a friction loss. There is a proper way to calculate the friction loss, which will better explained by the plumbing engineer. As I am an electrical engineer, so I could not able to explain in that better as the plumbing engineer will explain. But I will give you the overview, like for 2 inch of elbow, there is one friction loss in the chart. That friction loss they will consider and they will put the value here. In same way, for every fitting, they will put the friction losses. For every pipe size, the plumbing engineer will put the friction losses and they will add for full network in order to get the friction losses. But here, my topic is different, so we will not go in that deep. But to simplify the thing, what we will consider that the friction losses is 20% of the total geometrical length. Okay, whatever be the geometrical head, that 20% of the geometrical head will be considered as a friction head. So I will consider for the simplicity as 20% of the geometrical head is a friction head. Means suppose the pipe length is only 100 meter, but we will consider the resultant pipe length as 120 meter, because we are considering that the 20% head is by the friction. So we will consider the geometrical head as 120 meter. Hope you understood this head concept also. Now let us understand the basic formulas which we discuss in our school, that the mass is equal to velocity into density. Okay, the potential energy is mass into gravity into height. Okay, where the gravity value is 9.81 meter per second square. H is the head as I explained you. And for the water, the volume in 1 meter cube of tank, there will be 1,000 liter of water. What does it mean? Suppose if we are filling the water from this tap, then in 1 meter cube of water, there will be 1,000 liter of water will come. Okay. But if we are filling from this tap alcohol, then in this 1 meter cube of tank, 1,000 liter of alcohol will not come, because the specific gravity of the alcohol, the density of the alcohol is not same as the water. Okay. If we will fill from this tap to petrol, then this 1 cubic meter tank will not contain 1,000 liter of petrol, because the density of the petrol is different than the water. So here our topic is for the pump size calculation for water only. So we will consider for water the volume in 1 cubic meter, there will be 1,000 liter of water. This is standard, okay? And the density of water is 99.7 kg per meter cube, meaning suppose we fill the water in this tank. If we will weight it, then the weight will come 997 kg per meter cube. If the water is filled in this tank, then the weight of the water will be 997 kg per meter cube. These all are standard and fixed value. So what we discussed so far, that the mass is equal to volume into density, and the potential energy is equal to mass into density into height. Okay, and for water, 1 meter cube will contain 1,000 liter of water, and for 1 meter cube of water, the weight will be 199.7 kg. Okay, these are the basic thing in physics we learn in 6 or 7 standard, but these things will be helpful in order to size the pump calculation. Now, if you understood three things, that is the flow rate, okay, head, and this basic concept, mass, potential energy, and volume and density, then we can easily calculate the pump size. So let us move to our original topic, that is how to size the HP rating or the kWh rating for the pump. In our example, we are taking a water well and we have to design a pump which will deliver this water from the well to the water tank which is kept on the roof floor. Okay, so as we discussed in our previous discussion, that this will be the suction head from the suction port of the pump to the sump. Okay, what is the delivery head? From the delivery head of the pump to the delivery point of the water tank, so that is delivery head. What is geometrical head? The sum of delivery head and the suction head is called geometrical head. Hope you understood this one. Okay, so what is the potential energy at this water well and at this water tank? We will discuss it, okay, later. This water tank has a capacity of 500 liter, and our intention, our desire is to fill this water tank within 30 minutes. We have to select a pump in such a manner that this water tank will fill within 30 minutes. Okay, 5,000 liter of water tank should fill in 30 minutes. In first step, we have to calculate the mass of the water which is going to transfer in 30 minutes. That is, mass is equal to volume into density, which we see earlier in our discussion. So as this water tank has a capacity of 5,000 liter, and we discussed that 1,000 liter of water meaning 1 meter cubic of water, because 1 meter cube box will contain 1,000 liter of water. So 5,000 liter of water meaning 5 meter cubic, which is the volume of the water. Okay, so I wrote here volume is equal to 5 meter cube, and we discussed in our previous discussion that the density of the water is 99.7 kg per meter cube. So this meter cube will cancel, and the mass of the water will become as 490.85 kg. I will tell you one important point, but here it is not related to this video. Suppose I buy an apple of 1 kg. Okay, 1 kg apple I buy. So in Earth, in our planet, the weight of the apple and the mass of the apple will be same. But if we will check the weight of the apple, which is 1 kg in the Earth, and if we will weight it on moon, then it will be not 1 kg. But the mass of that apple in Earth as well as in moon or in any other planet will be same. In case of Earth, the weight and the mass will be same for every substance. But in physics, we are discussing as a mass because it is technical word. Because weight can change planet to planet, but mass cannot change. This is a different topic, but just for the information I'm telling you. So what is the weight of the water which we are transferring in 30 seconds? That is 4,985 kg, which is the mass of the water also, because we are discussing on same Earth. Hope you understood. Now in the second step, we will calculate the potential energy at the water well and the potential energy at the water tank. So what is the potential energy? Potential energy is equal to mass into gravity into head. So the head for this case, from the water well case, is what? Mass we calculated 4,985, gravity we know 9.81, and head is 3 meter, right? So 3 meter. So what I'm writing the units also, so you will not confuse, because in calculating the pump unit role is very important. If you will change the unit, then your answer will be wrong. So I'm writing the unit also, so you will understand it more clearly. So what would be the potential energy? 4985 kg into 9.81 meter per second square into 3 meter. So the potential energy is 146,708.5 joule. This kg meter square per second square is called joule. Okay. Now we will calculate the potential energy at the tank. So what would be the potential energy at the tank? P2 will be mass into gravity into delivery head. Okay, HD. So mass of the water is 4985 kg into gravity 9.81 meter per second square. Head is equal to 10 meter, which I wrote here. So what is the potential energy at the water tank level is 489,028.5 joule. Okay. Now we consider the friction losses also as 20%. So the friction head is equal to 20% of the geometrical head, that is 13 meter. So the friction head is 2.6 meter. So the potential energy required to move the water for friction head is equal to 132,037.6 joule. So what is the total potential energy? Total potential energy is equal to sum of these all, then it will come as 774.6 joule. So this is the total potential energy. Now we know that the power is equal to energy by time. Now we know the total energy required, okay, by the pump. Time, we know that in 30 minutes we need to deliver this 5,000 liter of water. So we calculated the energy required to move the water. Now we have to calculate the power. Power is equal to energy by time. So we will put the value of energy which we calculated in our previous step, that is 767,774.6 joule, which we mention here, 767,774.6 joule divided by time. Time here what? In second, right? But here it is mentioned in minutes. So I will multiply with 60 to change this minute into second. So when we will calculate it, we will get the value of power is equal to 426.5 joule per second. This joule per second is nothing but watt. So what is the power requirement? Rating of the motor in order to move the fluid from the water well to the water tank, which is of 5,000 liter in 30 minutes, is 426.5 watt. But as we know that there is a losses in the motor also, electrical losses. So what we will do, we consider that the motor is 80% efficient. So we need to divide it by 0.8 in order to get the actual rating of the motor. So it will cover the losses and the requirement for the fluid movement or water movement. So the actual rating of the motor which we require to move the water from the water well to water tank, 5,000 liter of water in 30 seconds, is 533.2 watt. If we want to convert in HP, then 1 HP is equal to 746 watt. Okay. So by this conversion, if we will change it, then we will get the HP value as 0.71 HP. If we will choose the next standard size, so the next standard size available is 0.75 HP motor. So hope you understood how to calculate the rating of the motor for our application. But here I gave you these many discussion, but by this discussion we can derive a direct formula, and by using a direct formula we can calculate the HP rating of or the watt rating of a particular motor. What is the derived formula? Power in kilowatt is equal to HP, that is the total head. What is total head? Total head is equal to the head due to suction head plus delivery head plus the friction head. So if we will sum up all these, then it will come as a total head. Or we can say that the total head is equal to geometrical head plus friction head, because geometrical head is sum of suction head and delivery head. So total head into flow rate, which we discussed in our video previously, Q. Flow rate into specific gravity of the fluid which we are going to deliver, divided by 367 into efficiency. So what is total head? Total head is the sum of suction head, delivery head and the friction head, that is 15.7. So I mention here 15.7. Q is a flow rate in meter cube per hour. As we know that the water is 5000 liter. In meter cube, we can say that it is a 5 meter cube of water. As we know that in 1 meter cube of water, there is 1000 liter of water. This we discussed in our previous step. So 5000 liter of water will be 5 meter cube of water. Okay, but the time need to deliver this water is 30 minutes. But we need to calculate the flow rate in hour. So what we will do, 30 minutes is equal to 0.5 hour. So I put the value as 0.5 hour. So 5 meter cube divided by 0.5 hour. So it will came as, after calculation, 10 meter cube per hour. So which I mentioned here, Q is equal to 10 meter cube per hour. Specific gravity of water is 1. Okay, it is a standard value. So I put the value as 1 divided by 367 into efficiency I took 0.8. Okay, so when I calculate this one, I got the value of 0.534 kilowatt. When we calculate it by step, then we got the power rating as 533.2. And when we calculated the same motor rating with the same condition by using the formula, then we got the power rating as 0.534, which is same, 0.534 and 0.533. This is in watt and this is in kilowatt. So if you will convert into the kilowatt, it will be same, that is 534 watt. Okay, so you can use this direct formula also, but I explain you all the steps to have the concept related to this formula. Otherwise you will just remember it to calculate this pump rating, but concept is important. So our required motor rating is 0.75 HP. I hope you enjoyed this video and you learned something new from this video. I know I took a very simple case in order to calculate the motor rating, but my intention was in this video to give you a concept, and by using this concept you can calculate the pump size in the practical situations also. I will wrap the video here itself. If you find this video informative, then please hit the thumbs up button, subscribe to my channel, share with your friend. Okay, we will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.